Hi everyone. I'm glad to introduce our work, Uni-Perceiver v2, which is selected as a highlight paper at CVPR 2023. I'll briefly summarize our work first. Vision foundation models, such as BAIT3 and COCA, has shown a great potential of solving different tasks with a general model. However, they still need fine-tuning to be adapted to a specific task, which is costly. Different from the foundation models, Uni-Perceiver v2 aims to build a generalist model, which handles a broad range of vision and language tasks with exactly the same model and weights, without any fine-tuning. Compared with all existing generalist models, Uni-Perceiver v2 supports more tasks and achieves much better performance. Moreover, we achieve competitive performance compared with the task-specific fine-tuned models such as Swin Large and Dino, with exactly the same model and weights. Vision foundation models, such as CLIP and COCA, has shown strong performance on a series of downstream tasks. They learn a general representation by large-scale image text pre-training and can be adapted to different downstream tasks. However, they still need fine-tuning and task adaptation, which makes them not general enough. Specifically, to perform task-specific fine-tuning, researchers are required to collect enough labeled data, design task modules, and further train the entire model. For thousands of real-world scenarios, you need to train thousands of models and store them for inference, which is costly. So here comes the question. How can we design a generalist model, which is capable of handling different tasks without fine-tuning? To build a generalist model, we face some difficulties. Firstly, different tasks have different representations and output forms. To handle them with a single model and weights, we need a general and effective architecture. Second, different tasks may conflict with each other when sharing parameters. Last, training with different tasks at the same time requires task trade-off, which is tricky. Most existing generalist models represent images as non-overlapping patches with fixed sizes. However, this is not flexible enough for modeling objects of varying sizes and shapes in images, making it difficult to handle localization tasks such as detection and segmentation. Therefore, we propose to encode images as general region proposals. Specifically, we employ a transformer-based region proposal network as the image encoder. For each image, K proposals is generated by the image encoder. Each of the proposals consists of the semantic, bounding box and mask representation, and they are encoded into a single vector as a token in the image feature sequence. In addition to the region proposals, we complement them with global tokens obtained by pooling the backbone feature maps, so that the image representation can also contain non-object background information. An SPE token is used to extract the feature of the whole sequence. Then, for output, we employ the unified task formulation proposed in our previous work, Uni-Perceiver. Different tasks are identified as different input set X and candidate output set Y. Given X in X, the task is defined as finding Y in Y with the maximum likelihood. With this, different tasks are unified in the same formulation, and we do not need any task-specific heads. For example, for image classification, the input set is the images, and the target set is the category names regarded as text. The representation of the image is the SPE token in the image feature sequence, while the representation of the category names is the SPE token in the text sequence. The formulation of object detection task is similar to the image classification task, except that the feature of each proposal comes from the general region proposal token. For image captioning, the thing is a little different. The input set is the image and the already generated text, and the target set is the candidate words, which is also known as the vocabulary. The SPE token is inserted into the end of the input sequence, whose feature is used to compute cosine similarity with each word in the vocabulary. The second difficulty is the task interference. To mitigate this issue, we use the conditional MoE proposed in our previous work, Uni-Perceiver-MoE. We also investigate the task collaboration and interference in our paper. In this table, we can see that naively performed multitask training hurts the performance of the image classification, retrieval, and caption task. With MoE, the performance of joint training can exceed the single task baseline, which indicates that the collaboration and knowledge transfer of different tasks can boost the performance. The last difficulty is the tricky optimization of multitask joint training. Most generalist models use a mixed sampling strategy in their multitask training, that is to say, in one iteration different tasks are sampled on each GPU, and their gradients are averaged during the backpropagation. In contrast to that, the unmixed sampling strategy, where all GPUs share the same task in one iteration, can increase the effective batch size of each task and reduces the synchronization cost between GPUs. However, since different iterations are doing completely different tasks, the gradients differ significantly between iterations, which causes training instability. To mitigate this issue, we propose task-balanced gradient normalization, which adaptively normalize the gradients of each task to stabilize the training with unmixed sampling strategy. With this technique, we can employ the advantage of efficient large batch size training, and the experiments show the performance is improved with the unmixed sampling and task-balanced gradient normalization. Here we compare Uni-Perceiver-V2 with existing generalist models on a range of tasks. Uni-Perceiver-V2 not only outperforms all existing generalist models in performance, but also supports core vision tasks such as object detection and instance segmentation that existing generalist models do not support. Compared with commonly recognized task-specific strong baselines that require fine-tuning, Uni-Perceiver-V2 also achieves competitive performance. Here is a brief introduction of our Uni-Perceiver series. Our code and models will be released soon in this repo. Thank you for listening.